So this would be absolute values part 2, which, if you're sophisticated, you know that means 2. So let's do one together here. So absolute value, I got to use a definition to break this up. So I'm going to assume the inside's, when it's positive, I just drop it. Then I'm going to take care of the case when the inside is negative. So notice what I'm talking about. If this number x that I put in for x is 10, 30 minus 6 is 24, that's positive. But if x was negative 20, it'd be negative 60 minus 6. Now you got negative. So you got to take care of both cases. Now it's greater than, so it's or. So then add 6, so 3x is greater than 27. Then divide by 3, x is greater than 9. Take the opposite. Subtract 6. So negative 3x is greater than 15. Divide by negative 3. Oh, divided by negative, guys, switch the inequality. Then it's an or. Or, that seems foggy right now. I don't know why. Sometimes it does that. Let's do this. We. I don't know why I find that funny. So, here's negative 5. We. Here's greater than 9. Oh, wait a minute. Oh, no. It's Godzilla. Go ahead and do this problem for me. Then turn me back on. Okay, 1/3 x minus 1 is less than or equal to 6. Then, and less than the opposite. Now I'm just going to skip a step here and just take the opposite of both terms. Save me a little time. So add 1. 1/3 x is less than or equal to 7. Multiply by 3. So here, subtract 1. Negative 1/3 x is less than or equal to 5. Multiply by negative 3. Oh, switch the inequality. So it's and it's everything in between. Hoo-hoo. Hoo-hoo. Okay, 2 more problems. Go ahead and try it. This is tricky. It's just an equal. See if you can figure out what the graph would look like. Go ahead and then turn me back on. Okay, so 5x minus 10 is greater than or equal to 20. Or the opposite. See, I'm saving a step there. Just taking the opposite right away. So I'm going to add 10. Divide by 5. Here's subtract 10. Divide by negative 5. So we. And then we. Then this one, 6x plus 12 equal 24. Or the opposite. Hoo-hoo. Subtract 12. Divide by 6. Here, add 12. Divide by negative 6. Now, there's no inequality, so there's no shading. You just have a dot, and you have a dot. Woohoo! Tricky. If you got this right, I'm impressed. Last problem we're doing for this set. Now, we, of course, have more videos, which some of you are not going to watch. Mercy. Now, whenever you have stuff outside, I don't know why I turned southern there. If you got some absolute value stuff outside, get the absolute value by itself. Now, you won't, and you will butcher this problem. But get the absolute value by itself. So I'm going to subtract 6. So negative 6, absolute value x plus 1 is greater than negative 18. Then I'm going to divide both sides by negative 6. Now notice what happens. This goes from being what you think's an or, but it's really an and. So we have x plus 1 is less than 3, and the opposite. So I subtract 1. Here I add 1. Take the opposite. So it's everything between -4 and 2. Open dot, open dot. Did I mess up? Nope, it is no equals. So, okay, just greater than, I mean, just less than, greater than at the start, but less than at the end. So, if you ever have stuff outside the absolute value, get it away. Get the absolute value by itself first and then solve it. I don't know why people won't listen to me and then they just butcher it. But anyways, hell, I'm going to be going.